Howdy, 8th grade. Today we are going to look at a technique called completing the square, which is going to help us solve any quadratic. And this one is very, very nice because we don't have to rely on being able to factor it. We're going to take an equation and we're going to make it so we can factor it whether it likes it or not. But first, I want to talk a little bit about what completing the square is. And what it is when we realize that any problem with a perfect square is really easy. So let's look at what a perfect square problem is again. If I have the problem x squared plus 4x plus 4, what's going to happen here equals 0. Is that I can factor this. And when I factor it, I would get x plus 2, the quantity squared, equals 0. So what I got by factoring, if I square root both sides, then my x plus 2 squared, if I take a square root, I'll just get x plus 2. And on the other side, I get the square root of 0. It'll be plus or minus 0, but positive or negative 0 is just 0. So I end up with x plus 2 equals 0. Solving that, I get x equals negative 2 by subtracting 2 from both sides. And that would be my final answer. And I really love this problem because it's a perfect square. So I end up with this thing here, and all I end up having to do is take its square root. And it solves it very, very nicely. But a lot of times we get these problems and we don't have perfect squares, and that makes me sad. Because perfect squares make my life easy. Squares are easy. So what we're going to try to do today is we're going to try to take any quadratic and force it into being a perfect square. So we're going to force a perfect square. So I'm going to look at a different problem real quick. So we just looked up here at x squared plus 4x plus 4 equals 0. But what if I had x squared plus 4x plus 5 equals 0? Well, it's definitely not a perfect square anymore, but there's kind of a perfect square in here that's hiding, and it's waiting to come out. So what I'm going to do is I'm going to just look at these two terms. So these are what I care about. What I care about. And I have x squared plus 4x. When I see this, I know that I can make a perfect square if I have x squared plus 4x plus 4. So that's what I'm going to do. I'm going to add 4 to both sides. X squared plus 4x plus 4 plus 5 equals 4. So I'm adding 4 to both sides there. And just like that, right here, I have a perfect square, which is exciting because I like those. So I'm going to go ahead and put those together, and I'll get x squared. Putting those together into a perfect square just like we did up top. If I factor it, I'll get x plus 2, the quantity squared, plus 5 equals 4. A little bit further on, I can now say x plus 2 squared equals negative 1. And now I come to a bit of an impasse. Normally I'd be able to square root this and solve it. For this particular problem, I have a negative number here, which makes me sad because I can't square root a negative number. It's one of those things I can't do. Square root a negative. And the reason for that is even if I take a negative and multiply by itself, I'll get a positive. If I take a positive and multiply by itself, I'll get a positive. So nothing times itself is going to be a negative, so I can't do this. So this would be no solution. But it's very nice to be able to show that I have no solution. A lot of the times in the past when we've been factoring things, we've just been able to say, well, I don't think there's a solution. Right here we have actual proof, which I think is one of the more beautiful things about the perfect square problems. So we're going to try something else. Hopefully get a solution this time. But we're going to look at the problem x squared plus 6x minus 5 equals 0. So So one more time, all I care about is this x squared plus 6x. And I want to try to make a perfect square with that. So the question is, what do I need to have to get x squared plus 6x? So I know I'm going to have two things, x plus, and both of these numbers should be the same. So really I'm looking for two numbers that add together to get 6 that are the same. Well, what plus itself is 6? I really hope that's 3. And so if I FOIL this out, what I'm going to end up getting is I'm going to get x squared plus 6x plus 9 equals x plus 3 squared. And this is what I want to use. So this right here is my perfect square. So I want to use this. And the number that I need to do that is a 9. So I'm going to start off with my x squared plus 6x minus 5 equals 0 again. But now I know that I want this 9 here. So what I'm going to do is I'm going to add 9 to both sides. X squared plus 6x plus 9 minus 5 equals 9. And then I'm going to write this part as my perfect square, because I just figured out how to do that. So it's going to be x plus 3 squared, because this is my perfect square up here, minus 5 equals 9. And when I'm done with that, I can add 5 to both sides to get rid of this. And I'll end up with x plus 3 squared equals 14. I can take the square root of both sides. I'll get x plus 3 equals plus or minus the square root of 14. And then subtracting 3 from both sides to get x by itself, I have x equals negative 3 plus or minus the square root of 14. Just like that, we are done. Kind of a simpler way to think about this if you're a visual person. What is completing the square exactly? The square. So why is it called this? Well, if I think about a square that I have that is, not what I want, x squared, which would be, I'm going to represent as a square that is x by x. And then on either side, I'm going to have an extra 1 here and a 1 here. This right here would be x squared plus x plus x. So this right now would be x squared plus 2x. And if we look at that, to complete the square, all we would need is to fill in this piece here, which would be a 1. So if I put a 1 in there, all of a sudden I am done. And I have a complete square, and that'd be equal to x plus 1 times x plus 1, because the area of this would now be this length times this length. And I can do this with any number of x. So if I start off with my x squared, and then I add 2x on either side, then I know I'm going to need 4 blocks here, 1, 1, 1, 1, to be able to make it. So this means that x squared plus 4x plus 4 is equal to x plus 2 times x plus 2. And how I got that, I have 1x squared, I've got 4 x's, I've got 4 1's, and then this right here would be x plus 1 plus 2, and over here would be x plus 1 plus 2. And that's kind of what completing the square looks like here. So in general, our last number is always going to be this number here. Third number is going to be equal to 1/2 of our second number squared. So if we look at examples we've used so far, this 4, if I have it, it's 2. 2 squared is 4. This 2, if I have it, it's 1. 1 squared is 1. And I believe I have a 3 up here. Here we go. This 6, if I have it, it's 3. 3 squared is 9. And that's a pattern that we'll always be able to use when we're completing the square. In any case, that's just a very simple way to be able to solve quadratics, even if they don't factor. That last problem we did, where we got the answer with the square root, didn't factor at all. We still got an answer for it, which is awesome. That's just a way that we can take all these things and be able to solve them more efficiently. So I'll see y'all in class tomorrow. Have a great day.